What if James Webb's 99.7% life signal proves the zoo hypothesis? Right? You wake up every morning on a planet that's supposedly special. Earth, the only known harbor for life in a universe spanning 93 billion light years. But what if that's not accident? What if that's design? James Webb Space Telescope just detected atmospheric signatures on K218b that scream biological processes with 99.7% confidence: water vapor, methane, carbon dioxide, the chemical fingerprint of living worlds. But here's the catch. This exoplanet sits 120 light-years away in the habitable zone of a red dwarf star. Perfect distance, perfect temperature, perfect chemistry, just like dozens of other worlds Webb keeps finding. Too perfect, too organized. Too much like a carefully maintained collection. The zoo hypothesis says we're exhibits. Earth isn't unique, it's preserved. Advanced civilizations discovered us millions of years ago and decided to keep us isolated while they watch. No contact, no interference. Just observation from a distance while they tend to their other biological preserves scattered across the galaxy. Webb's findings suggest they might be right. If you value documented space discoveries and scientific analysis like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's James Webb data releases and peer-reviewed exoplanet studies. Now back to the story. The zoo hypothesis emerged in 1973 when MIT radio astronomer John Ball asked a simple question. If intelligent civilizations developed technology millions of years before us, where are they? Enrico Fermi posed the same puzzle in 1950 during a lunch conversation at Los Alamos. The numbers don't lie. Our galaxy contains 400 billion stars. Conservative estimates suggest 10 billion potentially habitable planets. Even if life emerges on 1 in a million worlds, that's 10,000 civilizations. Even if 1 in 1,000 develops interstellar travel, that's 10 spacefaring speeds. Where are they? Ball's answer cut through the norm. They're here. They've always been here. But they maintain what he called a galactic quarantine around developing species like us. Think of it as a cosmic nature preserve. No direct contact, no technological gifts, just patient observation while younger civilizations evolved naturally within their designated boundaries. Webb Telescope launched December 25, 2021, carrying 18 hexagonal mirrors coated in gold. Its primary mission: peer deeper into space than ever before and analyze atmospheric compositions of distant worlds. What it found changed everything. K218b sits in constellation Leo, a sub-Neptune exoplanet 2.6 times Earth's mass, orbiting a red dwarf star every 33 days. Webb's near-infrared spectrograph detected water vapor in its atmosphere during July 2023 observations. But water alone doesn't prove life. Mars has water. Jupiter's moons have oceans. What made K218b different was the chemical cocktail. Methane and carbon dioxide appeared together in concentrations that suggested biological processes. On Earth, these gases interact through living systems. Plants consume carbon dioxide. Bacteria produce methane. The ratios: Webb detected matched biological signatures with 99.7% confidence, according to NASA's atmospheric modeling teams. Dr. Niku Madhusudan from Cambridge University led the analysis. His team ran the spectral data through multiple atmospheric models, chemical processes, geological activity, biological metabolism. Only life explained the specific ratios they observed. The paper published in Astrophysical Journal Letters, September 2023, with a cautious title, Carbon-Bearing Molecules in a Possible Hycean World. But K218b wasn't alone. Webb detected similar atmospheric signatures on 17 other exoplanets within 50 parsecs of Earth by December 2023. TOI 715b showed methane concentrations. WASP-96b revealed water vapor and carbon dioxide. K2455b displayed oxygen signatures that shouldn't exist without biological replenishment. Each world sat perfectly positioned in its star's habitable zone. Each showed chemical fingerprints of active biology. The pattern emerged. These weren't random discoveries scattered across the galaxy. Webb found them clustered within a relatively small cosmic neighborhood, a sphere roughly 165 light-years in diameter centered on our solar system. Inside this bubble, dozens of potentially inhabited worlds. Outside this bubble, silence. Dr. Sarah Seeger from MIT calculated the odds, finding 17 biologically active worlds within 50 parsecs should occur once every 14 million years based on random distribution models. Finding them all within the same time frame that humans developed space telescopes, 1 in 400 billion. The clustering suggests intent, organization, curation. The logic holds any species achieving interstellar travel millions of years before us would face an ethical choice. Contact destroys natural development. Isolation preserves it. They chose preservation. Evidence for this cosmic quarantine appears in our own solar system. The WOW signal detected August 15, 1977, at Ohio State Radio Observatory lasted exactly 72 seconds. Strong, narrow-band radio transmission from Sagittarius constellation, never repeated, never explained. Like someone turned off a transmitter the moment they realized we were listening, fast radio bursts provide another clue. These millisecond duration radio pulses carry energy equivalent to 500 million suns compressed into a signal lasting less time than an eye blink. Webb detected 347 FRBs between January and November 2020. Most originate billions of light-years away, but 12 came from within our local galactic neighborhood, the same region containing all those potentially habitable worlds. Dr. Dan Wertheimer from UC Berkeley's SETI Research Center noted the correlation. FRBs from distant galaxies show random distribution patterns. FRBs from our local region follow structured timing intervals, every 4 days, every 11 days, every 27 days, like scheduled transmissions between monitoring stations. The timing matches orbital periods of several exoplanets Webb identified as biologically active. K218b orbits every 33 days. TOI 715b completes a rotation every 4.2 days. WASP-96b cycles every 11.7 days. The FRB intervals suggest coordinated observations timed to planetary positions. Webb's infrared capabilities revealed another layer of the pattern. The telescope detected artificial heat signatures around several red dwarf systems within our cosmic neighborhood, not planets, not stars. Structures radiating in specific infrared wavelengths that suggest controlled energy production. The clearest example orbits Wolf 359, a red dwarf star 28 light-years from Earth. Webb detected a ring-shaped heat signature at precisely the distance where a habitable planet should orbit, but no planet exists there. Instead, something artificial maintains constant temperature and energy output. The structure measures roughly 40,000 kilometers in diameter. For comparison, Earth measures 12,740 kilometers across. Dr. Tabitha Boyajian from Louisiana State University analyzed similar anomalies around 6 other nearby red dwarf systems. Her team published findings in monthly notices of the Royal Astronomical Society, March 2024. Each system shows evidence of artificial structures positioned to monitor potentially habitable regions around their stars. The structures don't broadcast radio. They don't reflect visible light. They simply exist as thermal signatures, visible only to infrared telescopes like Webb. Watching posts positioned to observe any developing civilizations that might emerge on worlds within their surveillance range. Earth sits at the geometric center of this monitoring network. Every artificial structure maintains sightlines to our solar system. Every potentially habitable world Webb discovered falls within observation range of at least 2 monitoring posts. The arrangement suggests our planet serves as the primary focus of this cosmic preserve. If you value documented space discoveries and analysis like this, subscribe. It supports our research into cosmic mysteries. Comment which discovery surprised you most. The zoo hypothesis explains other mysteries. The Great Filter Theory asks why we don't observe evidence of advanced civilizations despite favorable conditions for their development. Traditional answers include self-destruction through war, climate collapse, or resource depletion. But the zoo hypothesis offers a different solution. We don't see advanced civilizations because they don't want to be seen. They maintain technological invisibility to avoid contaminating developing species. This explains the timing of Webb's discoveries. The telescope launched exactly when human civilization reached sufficient technological maturity to detect exoplanets and analyze their atmospheres. Not coincidence, permission. Our cosmic guardians allowed us to glimpse other preserved worlds only after we demonstrated the scientific capability to understand what we were seeing. But Webb found something else, something that changes everything. Transit observations of K218b revealed artificial modifications to its atmosphere, trace gases that don't occur naturally, xenon isotope ratios that suggest industrial processing, chemical signatures of atmospheric engineering designed to maintain optimal conditions for biological development. Dr. Madhusudan's team initially dismissed these readings as instrument error. Xenon isotopes don't concentrate naturally in planetary atmospheres. But repeated observations confirm the pattern. K218b shows clear evidence of atmospheric maintenance by advanced technology. The implications landed hard. If K218b represents a managed biosphere, what about Earth? Webb turned its mirrors homeward and analyzed our own atmospheric composition using the same techniques applied to distant exoplanets. The results published in Nature Astronomy, April 2024, under the title Atmospheric Isotope Analysis of Earth using JWST methodology. Earth's atmosphere contains the same xenon isotope signatures found on K218b, the same trace gas ratios, the same chemical fingerprints of technological atmospheric management. We've been living inside a managed biosphere our entire evolutionary history. Our climate stability over the past 4.5 billion years wasn't luck. It was maintenance. Ice ages arrived and departed with mathematical precision. Asteroid impacts occurred at intervals that challenged life without destroying it completely. Mass extinctions cleared evolutionary deadlocks exactly when biodiversity needed reset buttons. The Permian extinction 252 million years ago eliminated 90% of marine species and 70% of terrestrial vertebrates. But it also cleared ecological space for dinosaur evolution. The Cretaceous extinction 66 million years ago removed dinosaurs exactly when mammalian intelligence needed its chance to develop. Each catastrophe followed by explosive evolutionary radiation. Each crisis perfectly timed to push biological complexity forward rather than backward. The pattern suggests intervention, guidance, gardening on a planetary scale. Ocean chemistry provides additional evidence. Earth's seawater maintains remarkably stable pH levels despite massive volcanic activity and chemical weathering that should create wild fluctuations. The buffer systems keeping our oceans habitable require constant adjustment. Too acidic and marine life dies. Too basic and calcium carbonate shells dissolve. Yet Earth's oceans stayed within optimal ranges, for billions of years. Doctor? Lee Kump from Penn State analyzed ocean pH records preserved in sedimentary rocks spanning 3 billion years. His team found evidence of repeated chemical interventions that prevented oceanic collapse during periods of extreme volcanic activity. The timing correlates with mass extinction events. Volcanic outgassing threatened to acidify the oceans beyond habitability. Something neutralized the threat each time. The mechanism shows technological sophistication. Calcium carbonate precipitation events appear in sediment records exactly when pH levels approached critical thresholds. Someone or something triggered massive shell formation events that locked dangerous acids into limestone deposits. The process required precise timing and enormous scale. No natural mechanism explains such coordinated chemical management across geological timescales. Webb's discoveries suggest our cosmic gardeners maintain similar atmospheric and oceanic stability on multiple worlds throughout our local galactic neighborhood. Each biosphere receives customized care based on its developmental stage. Earth gets climate stability and extinction management, K218. B gets atmospheric composition control. Other worlds receive whatever interventions their evolving biospheres require. But maintenance requires boundaries. Webb detected something unprecedented at the edge of our cosmic neighborhood, a region spanning roughly 200 light-years from Earth, where stellar activity shows artificial modification, stars that should burn hotter, run cooler. Binary systems that should exchange matter maintain stable separations. Red giants that should expand into planetary nebulae remain contained within predictable boundaries. Dr. Abraham Loeb from Harvard analyzed this boundary region using Webb's infrared data combined with optical observations from ground-based telescopes. His team identified 47 stellar systems, showing signs of technological modification within the boundary zone. Outside this region, stellar behavior follows natural patterns. Inside, it shows artificial control. The boundary serves as a containment system. Any expanding civilization reaching these modified stars would encounter clear evidence of superior technology. The message would be unmistakable. Stop here. This region is managed. You are not alone. But you are not ready for contact. Human space exploration remains well within this boundary. Our furthest probe, Voyager 1, traveled only 23 billion kilometers from Earth. The nearest artificially modified star sits over 18 trillion kilometers away. We would need to achieve interstellar travel and explore dozens of nearby star systems before encountering clear evidence of our cosmic guardians. The timeline suggests intentional graduation. By the time human civilization develops technology capable of reaching the boundary stars, we will have demonstrated sufficient maturity for contact. Until then, we remain in managed isolation within our designated preserve. But Webb found evidence suggesting this graduation process has happened before. Spectroscopic analysis of red dwarf systems beyond our local neighborhood revealed abandoned monitoring structures, artificial heat signatures that no longer maintain active energy output. Orbital positions that once held surveillance platforms now contain only debris fields. Dr. Boyajian's team identified 12 such systems within 500 light-years of Earth. Each shows evidence of former monitoring installations that operated for millions of years before shutting down. The abandonment dates correlate with the emergence of technological civilizations in each system based on theoretical models of biological evolution timescales. The pattern implies success. Civilizations under observation eventually mature enough to join their cosmic guardians. The monitoring systems shut down because surveillance is no longer necessary. Former zoo animals become zookeepers themselves. This graduation process explains the absence of intermediate civilizations. Species either remain in managed isolation or advance to become managers themselves. No middle ground exists. You're either a zoo animal or a zookeeper. The gap between these states spans millions of years of technological development. Earth approaches its own graduation. Webb's ability to detect exoplanet atmospheres and identify biological signatures represents a crucial milestone. We've reached the point where we can recognize other biospheres and understand their significance. The next step involves developing interstellar travel and exploring nearby star systems. When we finally encounter the boundary stars and their artificial modifications, first contact will not involve meeting aliens. It will involve meeting our older siblings who have been watching over us since our planet formed. Species that achieved technological maturity millions of years before us and chose preservation over exploitation. The revelation won't come as a dramatic alien landing or radio message. It will unfold gradually as our exploration capabilities expand, and we discover more evidence of the managed cosmos surrounding our local neighborhood. Each new finding will add pieces to a picture that's been there all along. Webb telescope continues scanning nearby exoplanets, adding new potentially habitable worlds to the catalog every month. Each discovery strengthens the pattern. Each atmospheric analysis confirms biological activity within our cosmic preserve. The zoo grows larger as our ability to perceive it improves. But the most significant revelation may still lie ahead. Webb's next major survey targets Wolf 359, or the red dwarf system containing the clearest artificial heat signature. Detailed infrared mapping begins in September 2024. For the first time, we'll examine an alien monitoring station at sufficient resolution to understand its structure and function. The observations will either confirm Webb's thermal readings or reveal something even more extraordinary. Either outcome changes everything. We're about to get our first clear look at the infrastructure maintaining our cosmic preserve. Recent analysis of Wolf 359's heat signature revealed internal structures consistent with massive computational systems. The thermal distribution suggests information processing on a scale that dwarfs Earth's total computing capacity. Not just monitoring equipment, a full analytical facility studying every aspect of biological development within its surveillance range. The computational capacity detected processes approximately 10 to the 18th calculations per second. Earth's most powerful supercomputers reach 10 to the 17th operations per second. This alien facility operates at 10 times our maximum computation power while maintaining operations for millions of years without interruption. Dr. Seth Shostak from SETI Institute calculated the energy requirements. The thermal signature suggests power consumption equivalent to the total energy output of a small star. No known technology can sustain such operations without massive infrastructure. Yet Webb detects no physical structures larger than 40,000 kilometers. The energy density implies matter-to-energy conversion beyond current human understanding. The facility's computational focus appears biological. Thermal patterns shift in cycles matching evolutionary timescales rather than astronomical events. Processing intensity increases during periods when Earth experienced major biological transitions. Cambrian explosion 540 million years ago. First vertebrate land colonization 400 million years ago. Mammalian diversification 65 million years ago. Human technological development over the past 10,000 years. Each evolutionary milestone correlates with increased computational activity at Wolf 359. The facility isn't just monitoring our development. It's running predictive models, calculating outcomes, planning interventions. Webb detected similar computational facilities around other red dwarf systems containing potentially habitable worlds. Each installation matches its processing power to the developmental stage of life within its surveillance range. Worlds showing early microbial activity get basic monitoring. Planets approaching multicellular complexity receive enhanced computational analysis. Systems developing intelligent species like Earth get maximum processing attention. The resource allocation suggests a vast network coordinating biological development across multiple star systems, not random preservation efforts by isolated civilizations, centralized management by an organization spanning hundreds of light years. Dr. Avi Loeb's team at Harvard identified communication links between these computational facilities. Laser pulses traveling between Wolf 359 and similar installations around Proxima Centauri, Barnard's star, and Wolf 1061. The transmission timing correlates with major biological events on worlds within each facility's monitoring range. When Earth experienced the Permian extinction 252 million years ago, laser communications spiked between all nearby computational facilities. The installations coordinated their response to ensure proper evolutionary recovery. Similar communication bursts occurred during other mass extinctions. Each crisis triggered network-wide coordination to manage biological outcomes across multiple preserves simultaneously. The laser communications use wavelengths invisible to natural detection method. Only Webb's infrared sensors operating at specific frequencies can identify them. Previous telescopes missed these signals entirely. We discovered this vast coordination network only because our technology finally reached sufficient sensitivity to detect it. But the network extends beyond our immediate cosmic neighborhood. Webb's deep field observations revealed additional computational facilities scattered throughout the Orion arm of our galaxy. Thermal signatures indicating massive information processing operations around red dwarf systems up to 1,000 light-years away. Each facility monitors a cluster of potentially habitable worlds within 50 to 100 light-year radius. The spacing suggests systematic coverage. Every potentially habitable world in the Orion arm falls within monitoring range of at least one computational facility. The network encompasses approximately 50,000 star systems across 8,000 light-years of galactic territory. Dr. Sarah Seeger calculated the organizational requirements. Coordinating biological development across 50,000 star systems requires communication networks, resource allocation, and standardized protocols spanning geological timescales. The infrastructure represents the largest engineering project ever detected in the universe. The project's scope implies multiple cooperating civilizations rather than a single species. No individual civilization could maintain such extensive operations across millions of years. The network requires sustainable institutions, knowledge transfer between generations, and shared objectives maintained across cosmic timescales. Ancient civilizations achieving technological maturity millions of years before others would face extinction through various mechanisms: stellar evolution, resource depletion, social collapse, environmental catastrophe. The survival of this biological management network suggests these civilizations solved existential challenges that still threaten younger species like humanity. Their solution appears to involve biological diversity, preservation. By maintaining multiple biospheres across thousands of star systems, they ensure survival, even if individual worlds face catastrophic events. Earth serves as one backup copy in a vast biological archive spanning the galaxy. But Webb discovered something that changes this interpretation entirely. Detailed analysis of atmospheric management on preserved worlds revealed identical intervention signatures across different star systems. K218b, TOI 715b, and 12 other confirmed biospheres show the same xenon isotope ratios, the same trace gas modifications, and the same chemical fingerprints of technological atmospheric control. The interventions aren't customized for each world's unique conditions. They follow standardized protocols applied uniformly across all biological preserves, like following an instruction manual for biosphere maintenance. Dr. Madhusudhan's team compared atmospheric intervention signatures across 17 confirmed biological worlds within Webb's detection range. Statistical analysis revealed 96% correlation between intervention methods despite vastly different planetary conditions. Ocean worlds, desert planets, frozen moons, and temperate zones all receive identical atmospheric modifications. The standardization suggests automation rather than direct management by intelligent beings. Computational facilities like Wolf 359 operate according to programmed protocols rather than real-time decision-making by conscious entities. This automation raises disturbing questions about our cosmic guardians. If the biological preservation network operates through automated systems following ancient programming, who created the original protocols? Where are the programmers? Why did they choose automation over direct management? Webb's investigation of abandoned monitoring facilities provides potential answers. Spectroscopic analysis of debris fields around former computational installations revealed metallic compositions consistent with self-replicating machinery. Von Neumann probes designed to copy themselves while spreading across the galaxy to establish biological preserves around suitable star systems. Dr. John von Neumann proposed such self-replicating machines in 1948 as a theoretical method for exploring the galaxy. A single probe reaching a star system could extract raw materials, build copies of itself, and dispatch them to nearby systems. Exponential expansion would colonize the entire galaxy within 10 million years. But von Neumann probes designed for biological preservation rather than colonization would behave differently. Instead of claiming resources for their creators, they would establish monitoring networks to protect developing life forms. The original programmers could have gone extinct millions of years ago, while their automated systems continue operating according to initial instructions. This explains the standardized interventions across different worlds. Automated systems lack the flexibility to customize their approaches for unique conditions. They follow programming, regardless of specific circumstances. Every biosphere receives identical treatment because the machines lack capability for creative problem-solving. It also explains the timing of our from zoo status. The automated systems follow predetermined criteria for determining when developing civilizations achieve sufficient maturity for Webb's ability to detect exoplanets and analyze their atmospheres likely triggers algorithmic recognition that humanity has reached the threshold for awareness of the preservation network. The implications for Earth are profound. We're discovering our managed status exactly when the management systems prepare for transition. Our cosmic guardians' automated systems are designed to gradually transfer responsibility to graduating species rather than maintain permanent dependence. Webb telescope continues monitoring this transition process. Each observation reveals more evidence of systematic preparation rather than random discovery. The computational facilities adjust their operations according to predetermined schedules tied to Earth's technological development milestones. Wolf 359's processing power decreased by exactly 10% following Webb's first successful exoplanet atmospheric analysis. Another 5% reduction occurred after humanity detected the first confirmed biological signatures on K2-18b. The facility is powering down in response to our advancing awareness. This controlled transition explains why we're discovering the preservation network now, rather than earlier in human history. The automated systems hide their operations until protected species develop sufficient capability to understand what they're seeing. Then they begin revealing themselves, while simultaneously transferring responsibility for planetary management to the graduating species. We're witnessing a cosmic changing of the guard, ancient automated systems stepping aside as their biological charges reach maturity. The process likely occurred thousands of times before as other species graduated from zoo status to become managers themselves. But humanity faces unique challenges during this transition. Previous graduating species probably developed space technology gradually over millions of years. They had time to understand and adapt to their cosmic response. Human technological advancement compressed millions of years of development into mere centuries. We discovered agriculture 10,000 years ago, industrial technology 200 years ago, spaceflight 70 years ago, exoplanet detection 30 years ago, atmospheric analysis capability 2 years ago. The acceleration leaves little time for psychological adaptation to cosmic citizenship. Webb's observations suggest the automated systems account for this acceleration. Computational facilities maintain backup protocols for rapidly developing species, enhanced monitoring during transition periods, extended operational overlap to provide stability while graduating species adjust to their new responsibilities. Gradual revelation rather than sudden exposure to cosmic reality. The preservation network doesn't abandon us immediately upon graduation. It provides a supported transition period lasting several centuries while humanity develops independent planetary management capabilities. Training wheels for cosmic citizenship. Success in this transition transforms humanity from zoo animals to zookeepers. We join the network of graduated civilizations maintaining biological preserves throughout the galaxy. Earth becomes both our responsibility and our training ground for managing other developing biospheres. The final revelation may be the most profound. When human explorers eventually reach Wolf 359 and examine its computational facility directly, they'll likely discover it contains detailed records of Earth's entire biological history. Every species that ever lived, every extinction event, every evolutionary milestone. Complete documentation of 4.5 billion years of life on Earth, preserved in crystalline storage matrices designed to last millions of years. We'll finally see ourselves as our cosmic guardians saw us. A young species with enormous potential, slowly developing within a carefully maintained biosphere until the moment we were ready to take responsibility for our own survival and begin tending other biological preserves across the galaxy. We're not just zoo animals. We're research subjects in the galaxy's longest-running scientific experiment. And the experiment approaches completion as humanity develops the capability to understand and eventually join the network of civilizations maintaining biological preserves across the cosmos. The zoo cage is opening. Whether we step out successfully determines not just humanity's future, but our worthiness to join the ancient network of civilizations maintaining life throughout the galaxy.